Welcome to Study Loop.
We have a Newton's law of cooling problem, and when we read the section in the book, we see that the Newton's law of cooling problems fall into the same category as the exponential growth and decay, and we can make our model a little bit more specific. We can replace the y with T minus T sub s, where the T is the final temperature of the object and the T sub s is the temperature of the surroundings, and we can replace y naught with T naught minus T sub s. T naught is the initial temperature of the object, and T sub s is still the temperature of the surroundings. So for this problem, we know that the room temperature, or the surroundings temperature, is 20 degrees Celsius. We know that the cold drink started at a temperature of 5 degrees Celsius, so that's our T naught. And then we have one more piece of information, and we're going to use that to help us find the value of K in our model. So let's substitute some numbers in. So the temperature is 10 degrees. We're going to use that for T. And we have our Ts, which is 20. So 10 minus 20 equals, and then for T naught minus Ts, we have 5 minus 20. And then we have e raised to the kt, and the time is 25 minutes, so we have 25 times k. So we're going to use this to solve for k. So let's simplify it. We have negative 10 equals negative 15 times e to the 25k. Divide both sides by negative 15, and we have 2/3 equals e to the 25k. Then we can take the natural log of both sides, and we have natural log of 2/3 equals 25k. And we divide both sides by 25, and we get our value of k, natural log 2/3 over 25. So we substitute that into our equation, and we have T minus 20 equals T naught, which is going to be 5 degrees for the duration of the problem. So I'll just go ahead and have that 5 minus 20, that negative 15 there, times e to the natural log of 2/3 over 25 times time. So there's our model that we're going to use to find the answers to parts A and parts B. All right, so here's part A. We're going to find the temperature when the time is 50 minutes. So let's substitute 50 in for T, little t time, and solve for big T temperature. So we substitute the 50 in there, and then we compute the right side of the equation with the calculator, and we get approximately negative 6.7. So we have T minus 20 is approximately negative 6.7. Add 20 to both sides, and we have the temperature is approximately 13.3 degrees Celsius when 50 minutes have elapsed. Okay, now we'll move on to part B. And in this part, we're finding the time that it would take for the temperature of the drink to get to 15 degrees Celsius. So we're going to substitute 15 degrees Celsius in for capital T, and we're going to solve for lowercase t. Okay, let's go ahead and subtract 20 from 15. We get negative 5. Then we're going to divide both sides by negative 15. We get 1/3. Then we're going to take the natural log of both sides. Now, to get t by itself, we want to multiply both sides of the equation by the reciprocal of this fraction. So we're going to end up with t equals 25 times the natural log of 1/3 over the natural log of 2/3. And we put that into a calculator and approximate it, and we get about 67.74 minutes.